So in this video, we are going to create the binary tree if already given the preorder and inorder traversal. So before we start jumping into the actual problem and solving, let me give the basic idea what is the preorder, inorder and binary tree. As you can see, this is the binary tree. So if you want to know, draw the preorder, write the preorder for this binary tree, how we can do that. So whenever you do the preorder, always start from the parents, then left and right. So suppose one small tree is there, forget about the big tree. Suppose one small tree is there. For this, if you want to write the preorder, so what you have to write first? Parent. What is the parent? 25, then left and then right. For the same tree, if you have to write the in order, so you have to left. So 15 and then parent and then the right side. So this is how we write the preorder and inorder. So let us try to make the preorder for this bigger tree. Then we will understand that what is the preorder. So suppose if you write the preorder means OLR, right? So what would be like this? So first start from the parents. Parent is 25. So we write the 25. Then you have to go the left. But the moment you come the left, you can see this is another tree, right? If you see, this is another tree. If you consider this is another tree, right? This is another subtree. So again for this subtree, what is the parent? Parent is the 15. So again you have to start the parent from, right? Again when you come down, you can see another, this is the one more subtree, and for this is the subtree, right? If you can see, this is the another subtree, and for that what is the parent? Parent is the 10. So you have to write the 10, and then what is the left? Left is the 4 and right is the 12. Once you complete this part, now this is the subtree, right? And for this subtree, what is the parent? Parent is 22. In this case, we don't have the left. If you see, we don't have the left. So we will not write the left, we can directly write the right. So this part is done. So we have done the parent and we have done the left. Now the moment you go that side, again this is one more subtree, and for that subtree, what is the parent? Parent is 50. And you want to left, the moment you come to the left, you can see this is another subtree, and what is the parent for that? 35. And then what is the left? 31. In this case, we don't have the another child, right? So once you complete the left side, go to the right side, again you encounter this is the parent. So this is the parent and this is the left and this is right. So this is the preorder for this given tree. Try to write the inorder. Inorder means your parent would be the parent of this binary tree in the middle. So for this case, start from the left. So if this is the parent, what is the left here? And again this is the subtree, what is the left here? Again this is the subtree, what is the left here? 4. So you have to start from 4. Once you get the left, you have to find out the parent. Parent is 10. And this is the 12 is the right side. Once you done that, means you done the left subtree, then write the parent. And then again come to the right side, again you don't have the left, write direct parent. So 22 is the parent and this one is your right side child. This part is done, we have done the left side, then write the parent. Come here, this is another subtree, this is the parent, I will not touch, I want the left side. Again this is the parent, this is the left, I will start from 31. What is the parent? 35. For this there is no any right child, right? So we have done the left side, write the parent. And then again come to the right side, but again this is the parent, find out the left, then parent. So this is your pre-order and this is your in-order, right? But in this problem, you will having this pre-order and in-order, you will not have the tree. Actually, you have to make the tree. You will get the pre-order and in-order. This is the two array you have been given that, and from that you have to make the tree. Tree means you have to find out the output, because this is the output we represent in the form of array. So for this tree, this is the array representation. How it is that? So 25, 25, go through the width wise, 15, 50, 15, 50, then this way you go. If you see here, 4, 4, 12, 12, nothing is there left side null, so I can put the null here, right? And the same way this is done. So question is that you will have this pre-order, in order, and you have to make the this array, right? So that's why I explain all the basic things here, right? Let me just do some analysis here. So if you see that in the pre-order, the first element of the pre-order is always the root. So again, if you see, this is the 25, this is the 25. So you can say the first element of Preorder traversal is root, always. Whether this is a root for the main tree or this is a root for the subtree, but it always the root. So if you see here, we can easily find out from here, or do one thing, from here we will try to make one tree, and that you can see this is the equivalent this tree. Okay, so what we will do, this 25, the moment you get the 25, you can write the 25 here. This is your root. Now you search this 25 and you know what is, this is the array form. So of course you will have the index. Index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Obviously, the element must be the same in the both pre-order, in order, if you take any traversal, because they have traverse or the element. So first take the pre-order and the first element, that must be the root, and now you search this 25 where it is. So if you search this 25, I can get this 25 is here. And you have to find out the index of that. This index is very important. So the index is the 6. This is the index of the root element in the in order, right? So once you get the 25 as a root, you search the 25 in the in order array. Now you can see that in order what it is saying. If this is the parent, then the before the parent is the left subtree and after parent is the right subtree, right? So I can say that this complete part before 25 means from here to here is this your left subtree, and from here to here your right subtree. And you can see that all the element must be there the left side of 25, and this element must be there on the right side of the 25, right? So now we understand that 25 is our parent. Okay, now whatever the element is here, this is your left side element, right? So you can find out this element 4, 10, 12, 15, 24. It must be from where to where? It must be from till 24, right? So this element is your left side, and this from here to here, this is your right side. So you understand, this is your O, this is complete is the L, and this is complete is the R. In that case, this is complete is the L, this is the O, and this is the R, right? Now you think that this is also the left side element, and this is also a left side element, right? So just you make down what is the left side element. So left side element is the 15, 10, 4, 12, 22, 24. This is the left side from the pre-order, and this is the left side from the in order. 12, 15, 22, 24, right? And this element are the right side element from the pre-order. So I can say this is your pre-order and this is your in order. Here again for the right side, this is your pre-order. Pre-order is the 50, 35, 31, 70, 60 and 90. And from the in order right side, 31, 35, 50, 60, 70 and 90. Very interesting thing is that here we had this big array, two big array, and we find out what is the root element. Now we divided this array into the left, right. Now we do the same thing whatever we have done. Whatever we have done here to find out the root element, we will do the same thing here and here. And as you know that always the first element of the pre-order is our root. So definitely from 25 our root is the 15. And in this case, this is our root element. Of course, after 25, 50 is our the next sub-tree root, right? And say that we have to do the same thing. Search this 15 element in the in order. This is here, and take the index. What is the index right now? The 15 index is the 3, right? And what is that this index 15 element? 1 here. Here 15 is the 7. I tell you why I am writing that. And where is the 50 here? This 50 index is the 9, right? This is the index actually, don't confuse. This 1 is the index, 3 is the index, 7 is the index, 7 is 5 index, and 9 is the index, right? So now from here I made the two tree index pre-order to in order for the left and right side. We can do the same thing again here. So let us again what I will do. I will do again write the pre-order from here. How you can pre-order? This is the left side. So of course 4, 10, 12, this is the left side. This is the left side part. Okay. So what is that? 10, 4, 12. And other side part is that 22, 24. For this down, this is in order 4, 10, 12 and this size is the 22, 24. Means whatever we have done here, I done the same thing and I am doing the same thing here also. So again, this is the first element. So of course this is the root. So from 15 must be we have the 10 element. You can see. From 15 we have the 10. So we are trying to make the same binary tree what we have here, right? And again this is the 10, right? So this is the 10 from this side. From this side this is the first element. So this is the make the 22. You can see from 15 we have the 10 and 22. Again from 15 we have the 10 and the 22, right? And you can do the same thing here. So this is the 50 our element. So this part is the left side part. This is the pre-order part and the in order part is 35. Same thing here. This is the right side part and this is the right side part. So 70, 60, 90 and 60, 70, 90. Again what is the first element here? First element is the 35. So 35 is the parent. And here first element is the 70. So 70 is the parent. You can see here from 50 we have 35 and 70. Again from 50 we got the 35 and the 70. Right? Now make it again. So what mean to say that whatever we are doing here, we are doing the same thing here, we are doing the same thing here, we are doing the same thing here, means we are going to recursive approach. So you have to do one time and make the method call again and again and you will get your tree. What we have to do that till? So now if you take from here 10, right? So what is the left side here? Is the 4, remaining is the 4, right? This is the 4, this is the left side, this is the right side, right? So this side we got the 4, this side we got the 12. This is the approach. This is the understanding how we can receive that, right? Now I am going to tell you how we can achieve that. So if you understand that, if you see here, see carefully, from the pre-order, whatever above the left side, 15, 10, 4, 12, 22 and 24, this is this part, and these are the parent of the individual subtree. First was the 25, second was the 15, then the 10, then the 4, then 12, right? So if you start from the 0, so suppose if I start, we can give the starting of the start of the pre-order, or you can say that pre-order start. If you start the pre-order 0, second time, what is the parent here? Plus 1. Second time, then this one. So whenever you do the p start plus plus, you will be getting the root of the left side. But how you can get the root of the right side? So for that, what is the index? Index is 6. Next time your p start is the 1, right? If you see here, your p start is the 1. And for this 50 is the 7, right? So when you make the next time, your left side p start would be the previous p start plus 1, and for the right side your p start would be the index plus 1. What is our index? Index is 6, and this is the 6 plus 1, 7. So we have to take from the pre-order so that we can get it, and these are the this subtree root segment, right? So we have to always work the two things. One, we will use these things for the pre-order, and for the in-order, if you see the left side is always start from 0. If you see all the left side in order, it's always from 0. See, this index is 0, this index is 0, right? And if you see the ending is always the 12, right? So if you see here, that side is a 90, 12 index, that side is 12 index. So now you have to only consider the two things, this part 24 and this part 31. How we can get it? So if you see here, 24 is our index minus 1, and this 31 is index plus 1. So I mean to say that when you do the recursive, we need only the 3 information. What the information? What is the starting of the pre-order? What is the starting of the in-order? And what is the ending of the in-order? The 3 information we can take it, and our job is done, right? So how you will do that, right? So let me write the code and I will explain here. So we make one recursive method that is named the build, and I will pass the only 3 things. What is the starting of the in order, what is the ending of the end order, and what is these 2 arrays. One is the pre-order arrays and another is the in order arrays. So first I will pass what? I will pass the 0 because it's starting with the 0, and I will pass the length of this array minus 1. So I will pass the 12. First, and p start is from here 0, I kept 0. First we find out the root index, or you can, for time being, we can say the index from this array. So anyhow I know this element, or before that what we can do, that you make the tree, or we make the root, whatever the method is there, and we can make the new root from pre-order. So from pre-order, and we know the index is p start. I make the root, and I know what is the root element. This is the root element. Those root element I will search in this array. So you can do the one anything, index is equal to 0, make one for loop, then we start from the I start, go the I in, and search this index where it is that, and once you got, update the index. I will show in the code. So index would be the 6 in this case. So once I got it and I create the root also, right? So now I have to make the same, I have to call the same method for the left and right. So this is the tricky part here. So in this root, make one. So in this root dot left means you have to make the, I got a 25, now I have to make the left side child. I will call the same method, and this time if you see that, and what I will do, I will make the plus here. So no need to handle this. So once time this is 0, next time it is the incrementing would be there, right? And now if you see here the build I start, next time what is the I start? I start is the same I start what it was there, right? So this is the same I start, whatever the I start the same for the left side. And what is the ending? Ending is index -1, and the both array, preorder and the inorder. And for the root, for the right side, call the same method. This time you want this one, right? So what is that? Index +1. It will go the end is about the I end, and this two array I will send. So this is the complete logic that we are going to do in the code. So what happened? So next time when you came here, you will be get this index as a root. How you will get this index as a root? Because if you see here that P start will be incrementing, right? So when the P start will be incrementing, this time the 15, next time the 10, this time 14, this time 12, it will be making root by root, right? So you can get it. And you can see that what happened, because you are calling the left side first, so they will do all the left side operation first. So by that time, this your P start the first time 1, second time, first time 0, second time 1, second time 2, 3. So first time they will do all those things. If you see here 0, 1, 2, right? 0, 1, 2, 3, 4. Once it is finished the left side, automatically when you go the right side, your P start will be incrementing one by one. So if you see in the code, then you will understand better. So first and foremost, we will make one recursive method, and they will return the tree node, give the name of the build what we discussed, and we have to pass I start means the in order start, and I in means in order traversal end, and then of course we will pass the these two array, right? Preorder and Inorder. And for the first element of the preorder, I will take one global variable. So preorder start, so it's 0. So what you have to do the first element first. So first we make the root element, because we have the pre start, means if you see this preorder first element is the root element. I told you the first element of the preorder is the root element. So make one tree root. This they have already given that class. So now we got it one root, and for the next time I am doing the plus. So next time they will increment, right? And once you get it, then we have to find out what is the index, right? The index we have to find out how. We will search the index in the inorder table with the help of the root value, right? So take one root index variable, anything you can take, 0, and we will start the traversing, scan the inorder, and we have the starting and ending for the inorder, right? That's why we are passing these two value. So make one for loop, start from the I start, and it will go equal the I end, I plus plus, and we will search if in order I equal to root var. Root var is nothing, this is about the root value. If it is matching, then in root index keep your I value and break it. Now no need to go for the for loop, right? So now we have the index element, that is the important element, we got it, right? So what we have to do, we have to call this method again for the left side and the right side. I will do for the left side. What we have to pass, we discussed that we pass the as start is as it is, and for the ending we have to pass index -1 and these two element, those two array, right? So left side we make for the build method, and the same thing we do for the right side also, right? So for the right side, only difference is that it will start from the index +1. If you remember that when you got the root element, the main root element, then index, before indexing it was the left side, after indexing it was the right side. So index +1 and I in and those things, we got it, and we can return the root element root. But what is the termination conditions for this recursive? Any time when in order tree, if we exhaust all the element, we have to stop it. Exhaust means when your I start is greater than the I in, means we don't have anything, right? So check, whenever your I start is become the greater than the I in, you have to return the null, and just you have to call this method from the main method, return build, and you have to pass the I start, I end, and these two array, right? Preorder and inorder. And what is the I start? Starting time, it's always the 0 for the in order traversal. And what is the ending? Take the in order length -1, right? So this is the index, we got it. That much the code. Let me run it. This is the code. So he's saying that cannot find the symbol preorder. So preorder, right? This is the typo. And the in order, here is the again typo. Here there is preorder. Okay, preorder, in order. Lot of typo is there today. Yeah. So index, I have not taken the index. We have given the name root index. So you have to use the root index. Okay, so this is problem because we have to give this the termination as a first. So this is good if you get any error, right, while running the program. So this is accepted, and if you see in the case 3, I have taken the same whatever the example I showed in the whiteboard, the same preorder we have taken and same in order we have taken that, and if you see that this was the output and the same output we have given on the top of the whiteboard. So this is your complete code, and hope should not be any problem to understand this code. Let me again very short, let me go the only thing what you have to do, take the first element of the in order, that is your root, and root values represent the element, and then find out the index of the root inside the in order. So I'm searching in the in order, don't confuse, in the in order I'm finding out the root element. Once you get the index, then again call the left and right with I start index -1 for the left side, and for the right side index +1 and the I end. That's why this is the code it. If you any problems, give your questions on the comment box. I will try to help you out, and please don't forget to subscribe this channel to have a better growth for this channel. Thank you very much.